This is one of those problems where most candidates know the solution, but very few can explain why it works. And in interviews, explanation matters more than memorization. In real interviews, this problem tests whether you can make correct decisions under constraints, not whether you remember the formula. Let's begin.
The problem is we are given an array called height. Each value in the array represents the height of a vertical line or bar. The index of the array represents the position of that line on x-axis. When we pick any two lines, they form a container with the x-axis. The goal is to choose two lines such that the container holds the maximum water. As you see that this forms a rectangle, so the area of the rectangle will be determined by the width of this and the length. So here the length is this and the width is this. Width is this. The most straightforward approach is we try every possible pair of lines. Let's say we fix this height first and then try every possible combinations from this line. Then we move on to the next height and try every possible combinations from this and so on. As you can see, by doing this, we keep reusing the same lines in multiple combinations. This leads to repeated work and a quadratic number of checks. Even though this guarantees the answer, it does not scale for large inputs. By checking every possible pair, we guarantee the correct answer, but we repeat unnecessary work. Interviewers expect you to recognize that O of n square is avoidable here. So what will we do instead? So what is the core idea behind this? We begin with the maximum width. From here, the only way to improve area is by finding a taller height. The area is limited by the shorter line. So let's say if we drew a container like this, but if you see, the container would be empty from here. Logically thinking, the water will overflow from this because the container is not closed from here. So we should always draw a container using a shorter line. In this case, the container will be closed. So the area is limited by the shorter line. Moving the taller line cannot increase the height. So it can never lead to a better answer. At every step, we are eliminating impossible solutions safely. This one rule separates people who guess from people who actually understand the problem. So in this case, the area would be I minus j multiplied by the height of the shorter bar, as the area of rectangle is length into height. Let's walk through the solution step by step. Initially, L pointer will be at index 0 and R pointer will be at index n minus 1, where n is the length of the array. So this will be L and this is R. As we know, the area of the rectangle is width into height. Here, width will be calculated as R minus L and height will be calculated as smaller value. When L is 0 and R is 8, the width will be 8 and the height will be 1, since this is smaller out of these two. And the area of the rectangle will be 8 as it is width into height, and the maximum area will be 8. Now pointer with the smaller height will move forward. So L will move to index 1. Now the width will be 8 minus 1, 7. And height will be 7, as 7 is smaller than 8. Area will be 49 and the max area will be maximum of 8 and 49. So it will be 49. Now we will move the pointer with smaller height. So R will be updated to the index 7. We'll again calculate width will be 7 minus 1, 6. Height will be the smaller height, 3. And the area will be 18. And the maximum will be maximum of current area and the previous maximum area, 49. Now R is again less than L, so R pointer will move backward. Width will be 6 minus 1, 5. Height will be 8. Area will be 40 and max area will be 49 again. As these both are equal, let's move the right pointer backward. Updated width will be 5 minus 1, 4. Height will be the smaller one, 4. Area will be 16 and the max area will remain 49. As R is the smaller height, R will again move backward. Width will be 4 minus 1, 3. Height will be the smaller height, 5. Area will be 3 into 5, 15. And the maximum area will be 49. Value at R is again smaller, so R pointer will move backward. 3 minus 1, width will be 2. Height, the smaller height, 2. Area will be 4. And max area will remain 49. R will again move backward. Width is 2 minus 1, that will be 1. Height will be 6 as 6 is smaller than 8. Area 6 and max height will remain 49. If we move the R pointer again backward, L becomes equals to R and it will come out of the loop. So now the maximum area will be 49 and this will return 49 as the answer. And this will return 49 as the answer. At each step, we calculate the area and then discard the shorter line because it cannot help form a larger container. Each pointer moves only inward, so every element is processed once. Now that we are clear with the logic, let's walk through the implementation. We start with 2 pointers at the extremes to maximize width. We will initialize maximum area with 0 and will run this loop as long as left pointer is less than the right pointer. At each step, we compute the width and the area. We then move the pointer pointing to the shorter height because only that decision can possibly increase the area. Here we initialize left pointer to 0 and right pointer to the length of array minus 1, that is the last index. We start with 2 pointers at the extremes to maximize width. We initialize maximum area to 0 and will run this loop as long as the left pointer is less than the right pointer. Width will be the difference between the right and left pointer. And the current height will be the minimum of values at left and right pointer as the area is limited by the smaller height. At each step, we compute the area and maximize the area. We then move the pointer pointing to the shorter height because only that decision can possibly increase the area. This guarantees linear time without missing any valid container. Let's run the code. This is the expected result as we saw in the explanation. We start with 2 pointers at the extreme ends. In every iteration, exactly 1 pointer moves inward. Since each pointer moves only in one direction and never revisits an index, the total number of moves is at most n. Even though there are 2 pointers, the total work is still linear because every element is processed once. As we are not checking all pairs, we are eliminating impossible pairs only. This is not a nested loop. It's a controlled shrink of the search space. So the time complexity is linear. As we are not using any extra data structure, the space complexity is constant. The interviewer is checking whether I understand that the water level is always limited by the shorter line and whether I can make correct pointer movement decision based on that rule. A common mistake is moving the taller pointer, assuming a taller height will increase the area, which ignores that width is shrinking the line while the limiting height stays the same. In this problem, explaining why I move a pointer is more important than writing the code itself. Once I explain this logic clearly, the interviewer already knows I understand the problem.
If this explanation helped you understand the logic instead of memorizing the solution, you're preparing the right way. Master the pattern and the problem solves itself. Most interview rejections don't happen because of wrong answers, but because of unclear reasoning. Follow this series if you want interview thinking, not just interview answers.